Hi everyone, I'm going to solve this next problem. This has to do with phase change and the heat involved in phase changes. This is the next problem after the first introduction problem that we tried in the last video. So like I said before, it's really important that you start with a phase change diagram. Okay, so here's the phase change diagram. This is temperature on the y-axis, and this is heat on the x-axis, and we're increasing heat continuously. All right, in this problem, we're starting with with ice at minus 40 degrees Celsius. It's very cold ice, and remember, ice melts at 0 degrees Celsius. This water is going to go all the way up to 100 degrees Celsius, where it's going to become steam, and it's going to become all steam. Okay, so I'm going to run through the steps that we're going to go through in order to make all this happen. Okay. So the ice is starting at minus 40 degrees Celsius. That's incredibly cold. Now, when we add heat to that cold ice, we don't usually think of ice like this, but we're going to add heat to that ice, and the ice is going to become warmer ice until it reaches the melting point. And then the ice is going to melt at 0 degrees Celsius. And once all of that ice is melted, then the liquid water is going to get hotter and hotter. It's going to increase temperature until we get to 100 degrees Celsius. Okay. All right. And then it's going to become steam. It's going from liquid to gas. Okay. So there are this many steps. We've got the ice warming up, we've got the ice melting, we've got the water getting hot, and then we've got the steam, or the water becoming steam, all steam. That is 4 steps to this calculation. Okay, I'm just going to run these calculations, and I'll come right back. And then I'll talk through what each calculation means, okay? All right, so the first step, Q equals MCAT. We have a change in temperature, so we can use Q equals MCAT. The mass of the water, the ice, is 475 grams. The specific heat of ice, focus on that. That is not the 4.184 that we've been using for water. That would be for liquid water. This is solid water. Okay? And then that temperature change going from minus 40 to 0, that's a 40 degrees Celsius temperature change. So the amount of heat that went into that ice to make that happen is 39.5 kilojoules. Okay, so for part 2, 475 grams of ice is 26.4 moles of ice, in other words, water. All right, so the rest is, well, for each mole, it takes 6.01 kilojoules. So 6.01 kilojoules times the number of moles gives me the total number of kilojoules. That's the amount of energy that it's going to take to melt that ice. All right, so for part 3, it's pretty straightforward. We have 475 grams of water. This is the specific heat of liquid water. The water changed temperature from 0 to 100, so that's 100 degrees Celsius. So this is the number of kilojoules. For the fourth part, where we're converting liquid to all steam, we have 26.4 moles of water. Each mole is going to require 40.7 kilojoules. So that is that many kilojoules. Now, the entire process takes us from here all the way through here. The change in enthalpy is going to be everything here added up. Okay, and if I did all my addition correctly, the total change in enthalpy should be this. All right, that should be enough to get you started, to work through the homework for tonight, actually for Monday. And I'll leave it at that. All right, good luck, everybody.